Welcome to the Inspiration Tub podcast, exploring topics ranging from the nature of reality to personal and leadership development. Your host for this show is Dr. Ehssan Sakhaee.
Hello and welcome another
Yes. Hello.
session with our dear Emeritus Professor Gordon Fleming, my dear friend, since I was in the US a few years ago and we met at a cafe, and here we are connecting again after quite a while, actually. Gordon, it's been
Yes, actually it is. I'm wondering, do we remember exactly how many years ago that was?
this
I
would have
don't.
been this would have been just 1 month before COVID, so it would have been January
Ah,
20. So it's been
I see. Yes.
so would that make it
Right.
5 years? Exactly 5 years, wouldn't it?
Yeah.
Yeah.
Yeah, I guess so.
Time flies.
It sure does. It sure does. And
Um,
the guy that I was talking with when you first introduced yourself, he and I we still have weekly sessions. He comes over here on Friday mornings, and we spend an hour and a half struggling with quantum mechanics and general relativity.
oh, fantastic. Yes, I remember. And that's how I approached you because I overheard your conversation
His
with
name's Tom. Yeah, Tom.
Tom, yes, and I believe he's a statistician, is that right? Is and
Yes,
that's right.
yes.
So I've overheard the conversation around quantum physics and relativity, and I was like, okay, I need to talk to I need to talk. But here we are. We've had many sessions around different topics, including
Yeah, right,
the
right.
topic
Yes,
of consciousness, and that keeps popping up. But today
right.
our topic is why there is chaos at a microscopic level, but there's harmony and prediction at
Yeah,
a macroscopic level. So, and that's
yeah.
probably.
I think that the premises of that query are somewhat misleading. I don't think there is just uh, deterministic harmony at the macroscopic level. I think, in fact, that it's easier to find instances of chaos at the macroscopic level than it is at the microscopic level,
Hmm.
because at the microscopic level there are lots of physicists. I'm not one of them, but there are lots of physicists who believe that what really counts at the microscopic level is Schrodinger's equation.
Mhm.
And Schrodinger's equation presents a deterministic evolution of the state vector of any system, any microscopic system. Now, it's true that what is deterministically evolving via the Schrodinger equation is probabilities. In other words, the Schrodinger equation tells us that if you know all the probabilities for getting various results upon making measurements for now, then the Schrodinger equation will tell you exactly what those corresponding probabilities will be for making measurements at a later time. So, yes, on one hand, it's all probability and statistics because it's the probabilities that are evolving, but they evolve deterministically. If you know the probabilities now, Schrodinger equation will tell you exactly what the probabilities will be later on. The only thing that interferes with that on the microscopic level is state reduction, which traditionally we attribute as a result of measurement. Any measurements we make cause this collapse or this reduction of the state vector, this wave function, and the probabilities get reassessed, and that all has a lot of randomness in it. But the Schrodinger equation will then take over again after the measurement and tell you what the probabilities are going to be the next time you're interested in. On the other hand, at the macroscopic level, there are things like earthquakes, volcano eruptions, heavy storms, wild weather, like the wildfires in California, and so on. And we really can't predict those things. We like to tell ourselves that it's just that the theories are too complicated and we can't grind out a definite prediction for such things from the theories. But I think that's a kind of wishful thinking. I think that our theories don't really determine those things, and that there could be. I don't claim that I know this to be true or that anybody knows this to be true. I only regard it as a possibility that we can't rule out. That one could argue that it's probabilistic developments at the microscopic level which end up triggering things like earthquakes and volcano eruptions and wild weather. At least we're not in a position to know that that isn't true.
So, no, that's really interesting. So if we consider the number of possible outcomes, let's say at the microscopic level. So from my understanding, and please correct me if I'm wrong, but there is a finite number of possible outcomes. There's a finite number of possible outcomes at the microscopic level that Schrodinger's equation actually applies.
Well, that depends. It depends on the kind of system that you're looking at. There are many systems. How to say this? It depends on the number of variables that characterize the system you're interested in. And it depends upon the measurement resolution of your ability to observe and check what's going on. If your measurement resolution is finite, and it is true that virtually all our measurement resolutions are finite, they may get very small, but they're still finite, then strictly speaking, there's a finite number of possible outcomes in any given situation. But if you increase the resolution by reducing the uncertainty with which you make your measurements, that increases the number of possible outcomes. And strictly speaking, in the limit of infinite resolution of your measurements, which we never quite achieve, but we get better and better as we go along, in the limit of infinite resolution, there would be an infinite number of possible outcomes. And it's sort of just a pragmatic thing to say that the way we actually make measurements at any given stage in the development of our measurement technology, it's such that because of finite resolution, we can only get a finite number of distinct results. So I guess I want to say, yes, what you're saying is correct, but it's correct in a time-dependent way.
Yeah.
As time passes and our technologies get better and better, we keep increasing the number of possible outcomes of our measurements because the resolution gets higher and the uncertainty gets smaller.
So it's basically almost, so it's a function of resolution of measurement, essentially, number of outcomes.
Yes. And that's true both at the macroscopic level and the microscopic level. All the measurements we make at whatever level, there is always a finite resolution and a non-zero uncertainty in the results. And now there are many cases where the non-zero uncertainty, like you're uncertain about where something is located to within the diameter of a human hair. And, who cares about that, the diameter of a human hair? Well, conceivably, there are circumstances where you'd like to be able to make measurements of position with an uncertainty less than the diameter of a human hair. And in some cases, we can do that, and in other cases, we can't. And the things improve with time.
And I think what's really interesting is although as we increase the resolution, the uncertainty drops, but also the number of outcomes is increasing. So it's almost counteracting. It's almost to create a sense of, well, yes, the uncertainty is reducing, but the number of outcomes is increasing. So ultimately, we still have, and this is, I'm just visualizing this.
Right, right.
We still have the same amount of uncertainty about which one. Wouldn't it make
Well,
it
it's
kind of like,
certainly the case. It's certainly the case that at the microscopic level, the various uncertainty principles tell us that we're never going to get rid of uncertainty. Because if you reduce the uncertainty for one kind of measurement, you're guaranteed to increase the uncertainty for other kinds of measurements, position, momentum, energy, and time, so on and so forth. But with regard to your question about the counteraction of the increasing number of outcomes with the decreasing uncertainty of measurement, think of it this way. Suppose I have a brick. I have a brick about this long, and I believe there's something inside the brick that is not quite brick-like. I don't know, a piece of gold or a diamond or something like that. And I want to know where in the brick it is. Now, if I make a measurement with an uncertainty about half the length of the brick, then there are two outcomes. It's either in this half or it's in this half, and I don't know which. But then I might later on be able to make a measurement in which I answer the question, which quarter of the brick is the diamond? Is it here, or is it here, or is it here, or is it here? My uncertainty has dropped by a factor of a half, and my number of outcomes, possible outcomes, has increased by a factor of 2. And I can keep that going. I can get better at measurements, and I measure which eighth of the brick contains the diamond. Now I have 8 possible outcomes, which 16th of the brick, and so on and so forth. Each time my uncertainty in measurement is decreasing by a factor of a half, and the number of possible outcomes is increasing by a number of 2. Now, would you want to argue that that is an example of something counterintuitive, that because your uncertainties are decreasing, the number of possible outcomes is increasing? It seems to me that that's kind of inevitable.
Yeah.
That's the way it's always going to be. When we decrease measurements, we're going to increase the number of possible outcomes. And the reason we're so convinced that at the macroscopic level things seem deterministic is that, as far as we can tell, the only thing that limits how precisely we can measure and get values for anything we want is our technological capacity. In principle, there's nothing that limits our possible precision of measurement at the macroscopic level. But at the microscopic level, there is. We can measure position as precisely as we like, but every time we do, we may increase the uncertainty of our knowledge of momentum, and vice versa.
So could we call this the illusion of prediction?
We might. We might
So
indeed.
it's an elusive, never-ending game that, no matter how much we enhance our measuring devices and predictability of, whatever it is that we're trying to measure, whether it's weather patterns or bushfires or earthquakes and volcanoes, that it's and please, maybe it's an extreme statement, but it's impossible, ultimately, for us to be able to ever measure with absolute certainty an outcome of an event.
I think so. I think that's definitely the case. I don't think we will ever achieve infinite precision in measuring anything. Whether with the coming of quantum mechanics and the quantum conception of the structure of the microscopic world, there's also a distinction which is just a pragmatic one at the macroscopic level, but at the microscopic level, as far as we can tell, it's a fundamental distinction, and that is between quantities that vary continuously and quantities that vary discretely. And the primary example of quantities that vary discretely is angular momentum. Like the electron can have its spin up or its spin down in any direction, spin up or spin down, spin up or spin down. And that's it. There is no continuous variation from spin down to spin up. Whereas with something rotating at the macroscopic level and possessing angular momentum as a consequence of its rotation, it can be rotating about that axis or about any continuously variable axis. It can rotate at whatever speed you care for. And one can ask, it's puzzling, it's sometimes hard to get this across to students. How is it that a macroscopic ball can be made of electrons and protons and neutrons, and every one of those electrons, protons, and neutrons can spin down or up, down or up, down or up, and that's all. But you put Avogadro's number of them together to make the macroscopic ball, and because of the fact that their individual spins are oriented erratically inside the ball itself as a whole can rotate and have angular momentum that can vary continuously. To make the axis of rotation of a ball vary continuously from down to up with whatever rotation speed you like, you just have to have the various electrons, protons, and neutrons do a bit of jumping. Well, the ball seems to be moving continuously. The electrons and the protons and the neutrons are doing various jumpings. Yeah.
That's,
So
yeah.
So what do I make of that? I don't know.
I mean, ultimately, it is fascinating that in existence, everything is made of those protons and neutrons and empty space, mostly empty space.
We like to think so.
Which is not really.
There is the question of what is dark matter that people like to ask, and some people think that there are special kinds of particles that make up dark matter that we don't know about yet.
Yeah.
But other people say, no, there's no dark matter. It's just a modified force of some kind, and that's up for grabs right now. We don't know what dark matter is.
Yes. And going back to the possible outcomes, but also there are things that are certain. I mean, for instance, we know at some point that the universe will either collapse or there is the birth and death of the universe. I think, can we say for
certain?
But
now back up a little bit, because you started to say the universe will either collapse or, and then you never said the or
the infinitely continuously expand. Is that right?
Right. Yeah. Well, the thing is, that's what we tend to think, because our best theories seem to have those two outcomes as the most likely. But what about the possibility of a universe that is like ours right now, and it's expanding, but it asymptotically gradually slows down the expansion and then stops expanding, but doesn't collapse?
It
doesn't start to collapse. Now, if you would say, well, what kind of gravity force would we need in order to allow that? I don't know the answer to that. But the point I'm trying to make is that though our theories that we presently have tend to say the universe will either expand indefinitely forever, or it will eventually stop and then recollapse. That's what our theories tell us the two alternatives are. But maybe our theories are wrong. Maybe eventually the universe will do something that none of our theories allow us to take seriously.
Yeah.
And I think there's an awful lot that we don't know at present. And there's a tendency, especially with YouTube and the enormous numbers of podcasts dealing with science and physical science. And a lot of it's very good. I watch it an awful lot myself, but there's a lot of nonsense that goes on there as well. And one has to be very careful in deciding. For instance, in my opinion, we don't know that the universe started with a Big Bang. We have some evidence which extrapolated in the simplest possible way backwards in time tells us that the universe started with a Big Bang. But that extrapolation might be completely wrong. The James Webb Space Telescope keeps feeding us with data that we never thought possible previously, like the formation of galaxies much too early in a Big Bang universe.
Yeah.
We thought it would take at least a couple of billion years or something like that for galaxies to form. But it appears that there are large galaxies very, very far away that are extremely old and were formed something like 400 million years after the Big Bang, assuming there was a Big Bang. So there's an awful lot going on that we don't understand very well.
Yes. And I think I'm at a point where for the kinds of programs I'm building, and there's one which is universal leadership, is really returning to the most fundamental, foundational, evidence-based, approaches to life, so again, going back to the theory of the Big Bang, or whether it was a Big Bang or whether it's a big bounce or whatever. So there are
right
out there. But so, for certainty, can we say, and at both at a microscopic and a macroscopic level, that there is some evolutionary thing happening? There's an evolutionary path to everything. Can we at least?
I certainly think that I would say the evidence is overwhelming that the answer to that is yes. But while the evidence is overwhelming, it's still not a certainty.
Mm-hmm.
And you could put the question, well, if it's not a certainty, what do you suggest as an alternative to evolution? And I wouldn't be able to answer that, but I know that there are some life scientists out there who really think that Darwin didn't get it quite right, and that we don't evolve as much. At least we don't evolve as much as we think we do. We don't evolve, species don't evolve as much as we think they do.
A few years ago, Gordon, I thought about this, and I thought perhaps if we try to combine quantum physics and evolution, Darwin's evolution, maybe it was something around all possibilities being, for instance, a animal begins to mutate, or that some mutation takes place, and that mutation may have a better chance at life. So that that
Right.
that kind of that will survive, but then another mutation has a less chance of life. So that one kind of gets
Right.
exterminated and so on, and that kind of multiplies. So all the possibilities are just taking place, and the
Right.
ones that are actually more fit for survival survive. So that kind of makes sense from even at
Yes, I agree. That makes perfectly good sense.
So it's
It's
not, it's less about the animal trying to create something for itself so that it survives, but it's all just randomness
Oh,
which
yeah, 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 yeah. Yes,
causes
yes.
one. Now I don't know if that is a specifically what Darwin says, but I don't think that's specifically what Darwin says, because that's kind of it's about
Well, the one thing to bear in mind is that Darwin was working long before quantum mechanics.
yes.
So Darwin was working at a time when the physical science establishment was convinced that everything that happens in the world is ultimately, however poorly we may understand it, it's ultimately a consequence of deterministic laws. So whenever Darwin and Wallace and the others and those coming after them introduce probabilistic considerations in their analysis, especially when the concept of mutation became relatively precise, because I don't think, I may be wrong, completely wrong on this, but was Darwin in possession of the concept of mutations, or did that come later? I would have thought that came later. He
I
knew
would
that species changed, but
uh,
I,
I would have thought that came later, but maybe perhaps we can ask AI.
yeah, right, we certainly can.
I can't
Yes,
always 100, it's not always 100% accurate, but let's
yeah.
go and see.
And there's also the fact that there's one concept of mutation in which you simply say that certain things change probabilistically, randomly.
Yes.
It's quite another thing to say that the way these changes come about is by cosmic rays hitting gene structure in the molecular basis of the cells that make up an organism. That's a very detailed mechanism for mutations and evolution.
Yes. So
Um,
so I just did a kind of quick prompt on ChatGPT.
right,
Right. What I got is that Darwin was not aware of the concept of mutation as it's understood today. So there, and because on the origin of species, that was 1859, and the theories around mutation came about much later. I think Greg
yeah, right.
published it in 1866. So that's several years after
Yeah,
Darwin.
now that raises an interesting question. If he didn't have the concept of mutation, what language did Darwin use in order to describe the evolution of species?
I think it was variation, heritability, natural selection. So these were the kind of terms that
Right, yes,
which I find I don't find I mean I don't find it's exactly what we really should be kind of considering as evolution in its more precise sense of uh ran well and I I wouldn't say complete randomness, because complete randomness would also imply infinite possibilities, whereas that there's still a finite number of outcomes, but these finite number of outcomes again, this kind of links into what comes to mind is, let's say,
right,
parallel universes do exist, and everything's splitting into all the possibilities, maybe not in this universe,
right, right,
but ultimately, whether it's whether it's happening in our universe or a parallel universe, the all the possible outcomes are taking place, and sometimes some of those things survive, some of they don't survive. They kind of end up in one place and the other in another place, and so ultimately, so the reason I think this is really interesting is, if you really take this seriously enough, then and we may have touched on this before, this concept of fairness actually is elusive, that this is fair, this is not fair. I mean, all the possibilities are existing. How can you even talk about fairness? It's the reality.
Yeah, I don't. What would what does fairness mean in this context?
So okay, I'll give you an example, a very simple example. For instance, in our world, so we have rich and poor, we have you know we have some people that live, some people die, some people have health, some people have disease.
Right,
So
right,
these are different outcomes that are causal. There's some causal phenomena that took place sometimes thousands, sometimes millions of years ago that resulted in certain outcomes today, certain
right,
actions by beings. Sometimes there was agency, sometimes there wasn't. It was random or whatever it is, right? So
right.
question of free will and agency actually comes into play here. But ultimately, if everything is causal and there's some outcome that it results from some previous state of matter and energy and so on, and all the possibilities have to exist, then coming to that sense of fairness, that kind of dissolves in the human mind. If we really understand this at a practical level, then it's like, well, this is one of the possibilities. Like, what war happened? Well, Trump just won. Well, that was possible, and it was realized in this universe. Maybe in
Right.
a parallel universe, he lost, or he wasn't born in another one. Yeah. So what I'm trying to say is, at a very practical, deep level, it will reduce this sense of injustice in people's minds, that certain things are just and unjust and fair and not fair. Does that kind of does that come across when I'm trying to kind of articulate it in that way?
Yeah, I think it comes across. I I'm sort of surprised at the application of the concept of fairness and justice to the evolution of universes. I mean, think of the day roughly 66 million years ago when the Chicxulub asteroid hit the Earth, and within relatively short order, the dinosaurs were gone.
Yes.
Okay. Now, that was some people might say that was unfair to the dinosaurs.
So what I'm really trying to get at is that this is just an opinion, like fairness. This is just it's not at a fundamental level. It's just a perspective. It's not.
Yeah. I mean, I think I don't know this by any means, but I do believe that eventually Homo sapiens will no longer exist. And
And I
I
agree too.
don't
Yeah. Hmm.
say again.
I agree with that. The way we're going.
Yeah, but I guess I feel to some extent it's it's independent of what we're doing. What we're doing may hasten the day when Homo sapiens no longer exists. But even if we were doing much wiser things, much more sensible things, that the day would still come that Homo sapiens would no longer exist. Now, that can happen in a couple, at least, probably several different ways. One could be that we obliterate ourselves, we just wipe ourselves out by a third world war or something like that. But another way in which it could happen is that we just succumb to Darwinian evolution and we may evolve into a more impressive species than we are already, but we're still not Homo sapiens. Maybe we become Homo double sapiens or something like that. I don't know. But in some sense, we, as we presently exist, will be gone. We will no longer exist. And maybe if we don't evolve into a superior species, maybe the only superior species will be in other galactic systems. not in the Milky Way, but some other. I mean, who knows? There's no way of predicting these sorts of things unless we do something really stupid like the Third or the Fourth World War using thermonuclear weapons and stuff like that.
Yes, absolutely. Now, so I mean, what I find that these conversations about a more which look at these fundamental questions about existence, our evolution, and nature reality, I feel like if there is enough awareness and understanding of what we're talking about, at least even if we don't have the final answers, I don't think people become insane enough to go out there and hurt each other, hurt nature, because it just doesn't make sense in the grand scheme of things to do that. Because ultimately, I think survival is just a small component of evolution rather than a means to an end, because that's how I think that the primary mindset for Homo sapiens at the grand scheme, not, there being individuals who don't have that mindset, but it's about survival. It's like about survival of my group and my people and my country and so on. Whereas it's
Right.
actually a very short-term oriented mindset. It's like actually evolution, as you said, even whatever we do, no matter how wise and healthy, and we are going to be gone.
Yes.
Right.
Yes.
And knowing
Right.
that, how does that help us? How does that help us live a better kind of life? I mean, because ultimately, if we realize that life is not about survival, but about evolution, how does that
Right. I guess I would be prepared to say that an awareness of those considerations that you're mentioning is likely, not guaranteed, but it's likely to provoke people to pay more attention to questions of survival in part, but not only survival, also pay more attention to the question of improving the quality of life for the largest array of living organisms, and people in particular. And I think that's probably the case. And one thing that's very alarming about current political developments in the United States, if not elsewhere in the world, is that our federal government right now has pretty much been taken over by people who are inclined to be very repressive and very harsh in their judgments of people who disagree with them.
It's
And
interesting. It's almost like the irony of, there was some form of censorship about things that, but now it's coming to the other extreme, and it's actually
yes,
the same flavor, it's the same thing in a
yes,
different flavor. For some
yes,
reason, it quickly, again, this counteraction that is happening, it's no matter what we do, it's almost, for some reason, what comes to mind is exactly what's happening at that microscopic level, happening at the macroscopic level. There's
right, yes,
um
right,
but essentially, I think, let's say, I mean, from what we're talking about is when we reduce this extreme aversion to things, to politicians or groups or whatever it is, so in a way, I think what I'm hoping is the next evolution of humanity is transcending these extreme views about life and what is right and wrong, which is still happening. I mean, it is still happening in politics, it's happening in religion, but these extreme views are creating the conflict, the conflict that is
yes, yes,
international level across, different belief systems or different countries or regions, whatever. But essentially, I think and I'm hoping that I'm going to use the word consciousness, that human consciousness becomes high enough to not recognize that these are just perspectives and opinions and nothing more. They don't have any absolute truth to it.
Yeah, well, there will certainly, I mean, I would think already there exist people who hold that view. The trouble is, or at least part of the trouble is, that we don't seem to be in possession of any wisdom as to how to convince those who hold the harsh views, the views of the need, like the Proud Boys trumping around that city. I can't remember the name of the city anymore, chanting, "The Jews will not replace us. The Jews will not replace us." They are really convinced that the Jews would want to replace them. I mean, that's so weird, so bizarre for them to chant like that. And there are people who have such harsh lives that when they reach adult maturity, they're filled with all kinds of hatreds and angers at what they believe the world unjustly did to them. I don't think we have any understanding at all of what we have to do in order to successfully avoid large numbers of people reaching adulthood with such views.
Yes,
It's very hard.
It could take some. Again, there's not much certainty about how long our species will actually survive at the rate we're going. But ultimately,
Right.
if we do reach a point where, what I call the custodianship mindset, and it's also a very indigenous concept, that actually we recognize that we are the only species on our planet that can actually take care of ourselves and the planet more than any other.
Yeah.
So we've kind of
Yeah.
the other extreme, where we've become the most destructive species on the planet, which is destroying its own species and the planet, to the other
Right.
extreme, where we actually recognize that we have the capacity to take care of our own species, but also take care of our planet and replenish it. So how long it will take to get to that point where the insanity of these man-made identities, that I call myself whatever, and the other group, and
Right.
it's all constructed in the human mind, has no reality to it, and we're actually willing to go and fight and kill, and based on those man-made constructs of identity. So that insanity has to be at mass scale, be realized that we've become an insane species.
Yes.
But
Yes.
actually recognize that insanity, like
Self-destructively insane. Yes.
self-destructively insane, as self-destructively and planetary destructive, right? It's at the
Yes. Yes.
so I think that if more people recognize the insanity, and I know there are small groups of people who have recognized the insanity, and they're doing
Right.
hard, but I don't think it's at a critical mass to create a fundamental thing, because if it was at a critical mass to create fundamental change, then we don't choose governments that create that level of separation and destruction in at a national, international level. It won't happen. We have governments who say, this is insane, what are we doing to ourselves? Like, stop this kind of nonsense, and make peace, and let's take care of the planet. Let's actually take renewable energy and sustainability and regeneration, take care of the well-being of our own people around us, people globally. So I think there is an opportunity, but whether humans have reached that level of wisdom, as you said, to embrace that, and actually at least be able to live until whatever happens. Let's say another meteor hits the planet, and then that's the end of it. But it won't be in the hands of our own species. The destruction doesn't happen. But anyway, so I think there is A part of my work is actually try to have these conversations with my
Yeah.
students, raise that consciousness, because at the end of the day, it's about having these conversations and getting people to think about this and realize that,
Right.
because this is not about a new belief system, it's really about raising consciousness. It's about the awareness and understanding of reality rather than just another story that
almost all of the competing belief systems have been around for a long, long time. Yeah.
Absolutely. And we don't want to get too much into philosophy and religion, but essentially I feel even much of the spiritual and religious traditions have been misunderstood and misinterpreted largely, and I don't think even those kind of the messages in those kind of traditions actually promoted war and destruction. They don't.
Yeah. Very good.
Thank you so much, Gordon. It was so nice to see you.
Quite welcome. I enjoyed it. Yeah, good to see you.
I look
Take
forward
care.
to having a chat. Have a great one. Take care. Bye.
Thanks for listening. And if you enjoyed this episode, please subscribe to our podcast and feel free to drop us a 5-star review. This greatly helps others find the show so they can benefit from the content. See you next time.